Hello, my name is Caleb Luthai, and I'll be talking about copolymers. First off, what is a copolymer? A copolymer is a polymer made by a reaction of two or more different monomers which have units of more than one kind. Copolymers are a very important part of the plastics industry today. Copolymerization has allowed us to expand our range of polymers with different sets of properties and characteristics. Many applications require the properties of multiple polymers. Homopolymers cannot fulfill this need while copolymers can. Although when a copolymer requires the strengths of multiple polymers, it also takes the weaknesses of the same polymers. The properties of the polymers are averaged out when combined, meaning the strengths are not as strong and the weaknesses are not as weak. There is an exception to this rule in that a few copolymers utilize the full properties of the combined polymers. With copolymers, the plastics industry becomes even more vital today. There are different types of copolymers. First one being a random copolymer, in which is a copolymer that the monomers are arranged in no specific order. An alternating copolymer is a copolymer in which the monomers occur in an alternate sequence. This controlled order guarantees the copolymer is uniform and consistent. These two types of copolymers are the most common and economic copolymers found in industry today because of the ease and low cost of producing them. More types of copolymers include block copolymer, which is a copolymer that the copolymers occur in blocks, and a graft copolymer, which is a branch copolymer that there are side chains that are very distinct from the main chain. The side chains attach to the main chain at a single point and can either be a homopolymer or copolymer chains. Random, alternating, and block copolymers all average out the properties of the polymers used. This is because the polymers exist in a single chain structure. However, whereas graft copolymers utilize the full properties of the combined polymers and allow us to create highly specialized polymers. Graft copolymers are able to do this because they exist as a main chain as a backbone, and then the separate side chains that attach to that main chain. Here's a figure showing the structures of the different types of copolymers that I've discussed. Top one being an alternating, that shows every other one is a different monomer. The second one is a block copolymer, which they appear in this case blocks of 3. The third example is a random copolymer, where there's no defined structure, and the fourth one is a graft copolymer, which shows the side chains branching off of the main chain. Styrene butadiene styrene rubber is a blocky copolymer, meaning that it has the characteristics of a block copolymer but is not uniform. The styrene butadiene styrene rubber is used in the production of tires and the soles of shoes. Since it averages out the properties of the two polymers, styrene and butadiene, the styrene gives the rubber its strength, and the butadiene allows the rubber to be tough and elastic. This flexibility greatly improves the rubber's ability to grip a surface, which is needed in both tires and shoes. High-impact polystyrene is a graft copolymer. Therefore, it utilizes the full properties of the polymers styrene and butadiene. Commonly, high-impact polystyrene is used in an application that needs good impact resistance at a low cost. For example, household items such as a TV or computer housings or toys for children. There are also different types of blending copolymer. So the first one is a physical blending, which means you mechanically mix two or more polymers together. And this can happen with either compatible polymers or non-compatible polymers. Compatible polymers are polymers that share very similar properties and are soluble in each other. Non-compatible polymers are the opposite, meaning they don't share very close properties. While compatible copolymers are better for blending, it is rare to find for each application two polymers that are compatible, so the majority of blends are done with non-compatible polymers. The other type of blending is chemical blending. This is how you create all of the copolymers that I talked about earlier, including random, alternating block, and graft copolymers. It's done by chemical reactions, and this allows us to have more control over the synthesis of the copolymer and allows us to create a copolymer that more accurately fits our needs for a certain application. So we can handpick the polymers with the properties that we want and put them together in a more controlled fashion. This then leads to better properties of the copolymer. In conclusion, copolymers have greatly influenced the plastics industry by allowing us to utilize multiple polymers' properties at once. Using chemical blending, we can virtually create, with great control, a polymer that is perfect for any certain application. Thank you.